Welcome to more or less the middle of the 2021 Vermont Organics Recycling Summit, organized by the Composting Association of Vermont in partnership with the Vermont Agency of Natural Resources. This year's summit is being held during the International Compost Awareness Week, the largest and most comprehensive education initiative of the compost industry. For folks who might not know me yet, I'm Natasha Duarte, Director of the Composting Association of Vermont. I'd like to thank all of our amazing sponsors this year. That includes Community Bank, Eco Products, Vermont Natural Ag Products, Addison County Solid Waste Management District, Agrilab Technologies, EcoPixel, Nature Cycle, the Vermont Produce Program from the Agency of Agriculture, Food and Markets, and the Eco AmeriCorps program from the Department of Environmental Conservation. This session's featured sponsor is Vermont Natural Ag Products. You'll be seeing some pictures. They've worked with Brian Giroux on a composting, aeration, and heat recovery process. And so you'll be seeing some pictures when he gets into the session today of their setup, and you'll be able to learn a lot more there. And in the meantime, you can learn more about Vermont Natural Ag Products at their website here, vermontnaturalagproducts.com. So thanks, huge thanks to Robert Foster for being a perennial sponsor of the summit. I have two short announcements that I'd like to make before we get into today's program. During this summit week, we are starting, CAV is launching a multi-generational statewide art challenge called Changing Lives Through Compost, One Scrap at a Time. This came about when I worked with Paul and Winsong Kervik to create a 2021 food scrap story calendar, which featured photographs that they took of the different interesting images in their countertop compost bucket, and we compiled it there. And then a 4-year-old who saw this calendar on her grandmother's wall wanted to do her own art with food scraps and yard waste, and that's in this plate right here. I also just wanted to highlight some other food scrap-based art that was contributed to us last International Compost Awareness Week through some UVM students through the Compost Ecology and Management class. So just some different images of what food scrap art can look like. We do have a number of partners who are also helping us spread the word about this statewide art challenge as an outreach and education activity. And if you'd like to learn more or to get more involved, you can find more information about that on the Composting Association of Vermont website. The submissions will be featured on the CAV website, and then some selected submissions will be included in our 2022 calendar. Today's program, we're here at the 1 o'clock hour, and we're going to be talking about composting and heat recovery for the Vermont Phosphorus Innovation Challenge. Just quickly, we do have 2 more sessions later in the afternoon. The 3 p.m. session is going to be talking about improved compost fertility characteristics. And then we also at the same time at 3 p.m. have a virtual tour of the Chittenden Solid Waste District's organic diversion facility. And so I'm now going to stop sharing my screen so we can switch over. I'm joined today by Caitlin Hayes, who is the point of contact for the Vermont Phosphorus Innovation Challenge. She's going to be sharing a little bit more information about that with us. And then Brian Giroux, who is president of Agrilab Technologies Inc, is going to be sharing the work that he's done as part of this challenge. So thank you both for joining us.
Wonderful. So I think I'll just give a really brief introduction. Caitlin Hayes here. I work for the Vermont Agency of Agriculture, and I work in the Water Quality Division, and also have been managing the Vermont Phosphorus Innovation Challenge for the past, almost 3 years now. The Vermont Phosphorus Innovation Challenge was first initiated in April of 2018 by Governor Scott, and it's a combined effort between the Agency of Agriculture, the Agency of Natural Resources, and the Agency of Commerce and Community Development. And so VPIC's goals have always been to address the phosphorus imbalance that exists in the state of Vermont, and that exists for a handful of reasons, but the ones that we were focusing on here were mostly, in the agricultural realm, we have an imbalance of phosphorus that's caused by the importation of feed and fertilizer. And so we're thinking about how can we address this imbalance by making a closed loop in the state of our phosphorus, which is a really important nutrient in many ways for the agricultural community. And so VPIC was focused on using phosphorus by separating it and extracting it from various waste streams, and then generating a product that can be sold to generate a revenue or an income. I also apologize, I have chicks with me in my office right now, so you might be able to hear them in the background. They're partying right now. But so VPIC started in April of 2018, and we initially had about 27 different applications that were submitted. We had 16 different groups that were selected to come and give presentations to the VPIC leadership and evaluation team. And from that group, 6 different proposals were selected for stage 2 of VPIC, which included various amounts of funding for these groups to do a business and a prototype development. And then from that, 5 groups were selected for this 3rd stage of VPIC, which is where we are right now. And I've had the pleasure of being able to work with Brian for the past 3 years through VPIC. And it's just, the growth and the development of both Brian's project and other projects as well has just been remarkable. As everything else in this world, COVID has had some really large impacts on the timeline for some of these projects. And so VPIC is still ongoing, and folks are still, making moves on their projects. I'm going to let Brian provide some more intel and insight on his project and one of the other of the 5 groups, Digested Organics. I'll just briefly mention the other 3 groups that have been involved with this 3rd stage of VPIC, one of which is the Village of Essex Junction Wastewater Treatment Facility, and they've been working with UVM and several other entities to work on extraction of phosphorus and other waste from wastewater streams, which is quite unique. It's our only non-agricultural focused project in VPIC. And so this is working on a certain type of technology that generates a material called struvite in the wastewater streams, which generally is not something that you want to generate. But it generates this product that then allows for very efficient removal of nutrients from the waste stream. And also a really important component of this project is that it really increases the lifespan of the infrastructure that is wastewater treatment facilities, which are very pricey to upkeep. And so this project is still ongoing at this point in time. There's been a lot of work that has gone into the prototype, lots of capstone projects with UVM students. The lab was shut down for a large part of 2020. And so, we'll have more updates on this project in the next few months. And one of our other projects is DVO. They are an organization based out in Wisconsin. And they have been working with UVM as well to focus on the use of material that's generated from an anaerobic digester and to make that into a marketable Vermont-based fertilizer product. At this point in time, that project is navigating how to reach the appropriate moisture content of the material that's coming out of the anaerobic digester and then the DAF unit. And so right now, that's where that VPIC project is how do we even get this material to be dry enough such that it doesn't impact the yield potential of this fertilizer that could then be sold in a bagged product. And then our last VPIC Stage 3 participant is Green State Biochar. And they are a company based in Vermont that has been producing biochar from scrap wood in the state of Vermont, and had been focused on setting up a filtration technology that would be kind of like end of pipe for agricultural waste streams on a farm, whether that's dairy waste or milk house waste going through this filtration unit. And at this point in time, Green State Biochar has concluded their project working with VPIC. They are focusing on honing the consistency of their biochar production and working on the specifics of the filtration devices. So Green State Biochar is no longer working with VPIC at this point in time, but for all 5 of these groups and all of the groups that have been part of VPIC throughout the lifespan of this project, it's been such an honor to work with them, to see the innovative entrepreneurial spirit that's been presented in these projects to address a very real problem in our state. And it's really promising to see all of the progress that has been made and where we'll be when we can get some of these technologies up and running. So I'll be sticking around throughout the rest of Brian's presentation, and will be available for the question and answer period at the end. But at this point in time, I will kick it over to Brian so he can give you his presentation about his VPIC project.
Great. Thank you, Caitlin. Thank you, Natasha and Emma, and thanks everyone for joining today. So this first slide is more or less clipped right from the website that Caitlin is working with on the state. So I won't need to linger on that one. The first part of the presentation, I'm going to focus on this why and why we came to identify the need and further support what Caitlin said. So the Missisquoi Basin, this slide talks about some of the issues related to Lake Champlain specifically. There's phosphorus and water quality issues statewide, but probably the most notable issues are with Lake Champlain. The state of Vermont got into an agreement with the U.S. Environmental Protection Agency to reduce the levels of phosphorus loading. It's called the Total Maximum Daily Load, or TMDL. And it breaks the watershed up into, or breaks the lake basin into 17 different watersheds in Vermont, as well as a number of other watersheds in New York State and some parts of southern Quebec. What I'll call out on this slide is 2 of the biggest loading watersheds to Lake Champlain are up at the top. The northern end of the lake is Missisquoi, the Missisquoi River and the Missisquoi Bay. So that kind of straddles the Vermont-Quebec border, goes all the way into Orleans County and bits of Lamoille and most of Franklin counties. Otter Creek is more based in Addison and some into Rutland. So those are some of the big areas. Our company's based in Franklin County, so it's a lot of our effort you'll see is focused there. So this issue has not gone away. There's been a lot of great work, not only with farms, but with all areas of developed landscape, conservation practices. But for multiple reasons, we have not made as much progress on phosphorus reduction in recent years as people would like to see, given the amount of money that's been put towards this. There's been a lot of great research on trying to identify the most sensitive parts of the landscape that are, whether due to soil type, slope, or their land use, have a disproportionate amount of phosphorus loss into these different rivers and ultimately Lake Champlain. And in some watersheds, even with all the work that's been done on manure management or cover cropping, we've continued to see increased phosphorus loading. So small resolution here, but you can see some of the trend lines are still actually going up in some of these basins. And some of this is because of the nature of phosphorus. Phosphorus, you could say, is sticky. It is not, most of phosphorus are in forms that aren't soluble. So nitrogen is more soluble in terms of being percolating or infiltrating through the soil profile, or being volatile and leaving as ammonia as a gas, where most forms of phosphorus are physically attached to soil particles. So most of phosphorus transport is associated with soil erosion, with the physical manure particles, and that's how that phosphorus is carried into the lake. And because of that, there's a time lag. You may see improvements in a watershed that you've established more tree buffers, there's been good land use practices, but because that phosphorus in the sediment is now embedded in the river and lake channels and then in the bays, there's continuing to be phosphorus cycling in these water bodies, so you don't see an immediate downstream water quality response. A little more, another way to illustrate this is different watersheds obviously have different land uses. You can imagine Chittenden County is a lot more developed land use. So in the Missisquoi Basin in particular, there's a lot of loads that are related to agriculture, stream bank, which is a combination of in-channel and bank erosion, and forest. Typically forests don't generate a lot of phosphorus per acre, but in a lot of these mountainous and large rural watersheds, they cover quite a bit of the land use or land area. So they add up to be a significant total. This next slide also is going to illustrate that. I'll point out down near the bottom, the Missisquoi Bay, the scale of the reductions is a little daunting. This is a 20-year agreement with the state and the EPA, but some of these watersheds have massive reductions that were agreed to. So again, some of the conservation practices and programs, both through regulatory and incentive programs, have been trying to address this. But I believe the intent of the Vermont Phosphorus Innovation Challenge was to try to find yet other pathways to come across some solutions to address this phosphorus loading issue. So just some broad methods that have been incorporated in those existing programs and general best practices in general is strategies that have been known and need to be employed in more widespread. So manure applications are obviously a big one related to dairy and livestock agriculture. You've got an existing winter spreading ban in place for part of that. A lot of the nutrient management plans talk about setbacks from streams, application rates, and other things are also combined with good soil building practices. So reducing tillage, maintaining vegetative cover, building soil organic matter. And then Caitlin addressed this a little bit, the phosphorus mass balance. So most farms, in terms of dairy farms, are bringing in grain concentrate from the Midwest in addition to supplement the forages of corn silage and haylage that they grow locally. So we are bringing in more phosphorus into Vermont in these agricultural watersheds than is being exported in milk and meat. So how do we manage that balance? And then the other one I really want to emphasize is a lot of the existing programs and practices have been set up for what our weather's like been in the past. So whether that's planning for the 25-year storm or having enough storage or setbacks. But what we've seen in terms of the Lake Champlain is the majority of phosphorus is transported to the lake in only 10 or 15 days out of the year. So it's those big storm events, it's those big spring melt-off run events where the majority of phosphorus is finding its way off the landscape and into the lake. So how do we plan practices that deal with that reality? And this issue is not going to get any easier. I highlighted the fact that very heavy precipitation events, I believe that's defined by an inch of precipitation or more, have increased 71% over the last 40 or more years. So we're seeing those heavier storms. It mobilizes more sediment, more erosion, and ultimately more phosphorus. So we're going to have to set up everything from our road networks to our farm fields to our farmsteads a little differently. So that's the context in which we're trying to address this. So narrowing it back in to the VPIC project, there have been some interesting and proven technologies that have been developed, some of them in wastewater treatment, some of them in agriculture, and they have been shown to capture high rates of phosphorus in manure or other waste streams. They are not widely adopted yet, and a lot of it is their cost. So there's a handful of these devices that have been installed in Vermont. The outputs of them can be called a phosphorus cake or a concentrate. There's just these incentives are new, but they're expensive. And then one of the other barriers that we saw was the outputs from the system, and I'll show some more pictures and examples of these. They're new, so people aren't used to working with those outputs, the cake or the concentrate or the DAF sludge. People aren't familiar how to use them, so there's not much of a demand. And oftentimes they're dense, they're wet. The whole mentioned DVO is trying to figure out drying. So trucking becomes a barrier for getting them any transport distance. So really to address this, we'll have to look at these new supply chains and figure out all these pieces of the puzzle, from how to work with all the various companies involved in equipment, to the farmers, to how to process it, get it out to the end users, and make this all economically viable. So looking at a range of different outlets and going from these different scales of demonstration to putting it into actually implemented practice. All right, so I'm going to actually, the models that from this next part is actually going to talk about not only our work, but one of the other teams that's gotten funding through the Phosphorus Innovation Challenge, and that's Digested Organics. They are based in Michigan, and they have a liquid treatment technologies, including ultrafiltration. My best analogy is it's similar to reverse osmosis that some maple sugar makers use to concentrate the sap. So there's less wood or other fuel burn to boil the sap down into syrup. So they have a series of devices, but one that we're working with most closely is an ultrafiltration unit. So they have implemented this in other states, and not only work in the dairy and livestock industries, but also with food and beverage manufacturers. Pretty interesting and remarkable projects that they've got in. So their model for these different stages of the Phosphorus Innovation Challenge was to have these hubs of processing centers, both of the filtrate, but then of where to aggregate them and process it or potentially blend it into higher value products that could then be put into agricultural or landscape use. So ultimately looking to redistribute these phosphorus-rich products both within the watershed as well as export it from the state in the watershed if possible. These next slides talk about their typical process. If some of you may have seen the virtual tour of the Vanguard facility at the Goodrich Farm in Salisbury earlier this week, but those are screw press separators or fiber separation. So I believe there's around 50 or so farms in the state that have these devices. They can take the slurried dairy manure or liquid manure, run it through a dewatering device, typically a screw press, and it creates these large it recovers the large fibers. So those large fibers are often either used as an input to composting, or they're used as recycled bedding for the livestock. The ultrafiltration then takes the resulting liquid that's had the coarse fibers removed, and then they run it through, again, these devices to squeeze out or permeate through the tea water or filtrate, and then leave a thicker sludgy concentrate at the center. And at least in manure, the biggest fraction of the phosphorus is held in the fine particulate. You may remember I said phosphorus is sticky. It sticks a little bit to those coarse fibers. Some of it stays suspended, but the biggest fraction sticks to these fine particulates, the small amounts of organic matter. So the device is set up to capture that fine particulate and keep it in a somewhat viscous form, about 90% moisture, 10% solids. I have not been brave enough to drink the permeate or the concentrate yet, but they've got some nice beer mugs if you ever chose to. But you can see the clarity of it after it goes through their system. And just some lab samples of it at the different stages, the digestate being the raw input material after the screw press, then the permeate and the concentrate. Most importantly, 98% removal of phosphorus in ideal conditions. So the conceptual high-level benefits are you've able to have your phosphorus concentrated in different forms, and you can target where that's applied to the fields that have the phosphorus need for growing that corn silage or other crops, and you can apply at higher rates that permeate and distribute it. Oftentimes the fields closest to the barn have had historically more spreading of manure and higher soil phosphorus levels. So you can apply less material to those and more material to the fields that are further away. This is one of their full processes, just so they have sites that actually take this step all the way from dewatering to the ultrafiltration to the permeate, an additional reverse osmosis step, ultraviolet disinfection, and then can discharge clean water to a waterway. So I believe they've been permitted to do this in one or more sites in Wisconsin. What we're doing here in Vermont in collaboration with Digest Organics is this more three-step process. So 1,000 gallons, you remove about 10% of it in terms of those coarse fibers, and then the remaining 900 gallons gets sorted into 225 gallons of concentrate typically, and then that permeate typically in most cases will just go back to the manure lagoon and get land applied as previously. All right, so we teamed up in stage 2, and they were happy to work with us to see if we could blend their concentrate into batches. So we started the mixing at a bucket scale, 5-gallon bucket scale. Then we went to the bucket loader scale and did different scale batches. So you can see the recipe there. It was about 10% concentrate mixed in with separated manure solids and some wood chips. It turned into a good batch that physically looked very similar to other compost that you would normally buy. Most importantly, the 3 times the total phosphorus. So in terms of having a fortified compost product that would be appropriate for applying to a field that had both a need for organic matter and for higher phosphorus fertility. So certain crops like corn silage, peppers, pumpkins, hemp, some of those crops still have a significant fertility requirement of phosphorus. So those may be some of the best matches for a product like this. Digest Organics also did some modeling of how they could set this up and replicate it in Vermont. So this is some work I believe they did with Middlebury College and looked at different places in the Missisquoi Basin in Franklin County, in the Winooski Basin, Winooski River Basin in Chittenden County, and then down in Addison County, Otter Creek, where they could have these centralized facilities and potentially bring in phosphorus concentrate from a range of farms, do some centralized processing, and then redistribute it. So at least they set up a conceptual model and did some estimated costs. So parallel, we were doing our own work and got to collaborate with Digested Organics on some pieces of this. Our company, to step back, has been working on composting projects for a number of years, and our biggest focus is on the systems that both aerate compost piles and recover heat. So primarily the benefits are for process acceleration and control, but we're also able to extend winter operations and then use the recovered heat from the process, just like solar thermal or geothermal, where we get heated water and glycol, and we can heat greenhouses or shop floors or preheat wash water on farms. And then more recently, we're applying that to a second heat exchanger to dry down compost or other products before they're screened, bagged, or transported. So using these processes and equipment that we've developed, we thought that this project was a good fit for that because we're dealing with these high moisture, dense products. So how can we add value to those?
I just got off the phone with Dustin. I just got off the phone with the vet. Dustin's doing well.
All right.
Sorry about that.
Not a problem. I'll keep plugging. So we set up some prototypes in the stage 2 and got to work, as you saw with the sponsor, Vermont Natural Ag Products, the Foster Brother Farms in Middlebury. So we tried to do a number of prototyping tests for everything from the process to the products that would be attractive to end use markets, but also economical to make. So here, if you haven't seen it before, is Vermont Natural Ag Products in Middlebury. So one of the largest, if not the largest site in the state. All those are long rows of compost. It's a certified site with stormwater drainage, those big ponds, and associated with their dairy farm where they have 400 or so animals. So their facility is great because they have experience in handling all kinds of materials. While it's a lot of it's manure from their own farm or for other farms in the state, some of it being raw, some of it being out of digesters. They also handle everything from forestry residuals from mills in Bristol, sawdust, bark. They handle horse manure, poultry manure, and then all kinds of other inputs, including food scraps from the Addison County Solid Waste District. They have different formulations to make their own kind of base blends, and then they blend at the end of the process as well to get their 12 or more bagged products that they sell in 10 or 12 different states. It was also a good fit to work with them because we have been able to sell them a couple pieces of our compost aeration and heat recovery equipment. You can see in this slide, the shipping container is where we have our aeration equipment in, which I'll show you an illustration after this, but it pulls the vapor through those piles out on the pad, through pipes underground, up into the container, through a blower and heat exchanger equipment, and then you can kind of make out the steam coming out of the pipe at the top of the container. So that's exhaust coming from those piles sitting at the pad. This schematic or process flow diagram shows that in a little more detail. You can picture this equipment sits inside of that shipping container. So we have different ports that this connects to for the piles out on the pad. There's an aeration blower that provides the suction to draw fresh oxygen into those piles so that it speeds up their process. It draws that vapor across a specialized heat exchanger in the center of the equipment. So that's where the water and glycol loop is heated up for on-site use. We also have a lot of sensors on here. So we're able to track temperature, oxygen levels, the flow rates, and use that to adjust controls in terms of how long each batch is aerated, at what level of fan power. And then ultimately, through controlling a series of valves, we can either exhaust the vapor out to the air, like you saw that plume of steam, or if a pile is cold or freshly mixed in the winter, we can push hot vapor into another pile in order to boost its temperature, get it started, and not have to be in cold winter hibernation mode. The takeoff, again, is this the water loop. So here we've got a water loop that could go anywhere to heating the shop floor or bagging building on the site, or to a second heat exchanger where we can heat up ambient air and direct through positive aeration into these piles. So again, spending the time on this process step to share how we use this renewable thermal energy that's already present in the composting process to then do some of the drying that in most commercial applications is done with the assistance of propane or heating oil, electricity, or some other fossil fuel source. So we're not able to perhaps reach the same peak temperatures but 150-degree air being forced through materials certainly is a good batch drying process, and we were able to show that in this. This next slide shows some of, I like how this illustrates, this is the source of energy that we're working with. So it's a cool looking picture. It's actually their straddle turner just went through the windrow. So the pile gets all blended and mixed, but you can see how much steam, both water vapor and carbon dioxide, is released when that happens. For the piles that they have that are solely turned with windrows, they may turn it 14 times over a 4 to 5 month period. And with the aeration, they need to do it less. They maybe turn 6 times over a 2 to 2.5 month period. The point being, though, is all that steam and energy that's going off into the air is instead being pulled through that pipe network into that heat exchanger, anywhere from 10 to 12 times a day based on a time schedule. So that's our thermal input. That's our energy input to the system, and that's what we're taking advantage of here. And in this case, for VPIC, we were directing that energy to drying down some of those phosphorus residuals, concentrates, and compost blends. All right, now here is the concentrate. So this was at the bucket scale blending when we were first trying to figure out the best proportions. But this is the concentrate from digested organic. So you can see it's a thick material, but it's very homogeneous and it flows. So in that sense, it was the most attractive phosphorus concentrate or residual to incorporate into a compost batch. Again, impressive that 95% of the phosphorus is concentrated into that original 25% of the liquid manure. We talked about the DVO, dissolved air flotation sludge. So this is also very effective at removing phosphorus from the material, but it was very difficult to then handle this material and incorporate it into a compost blend. We literally had to use 3 times as much amendment of wood chip, bark, sawdust, manure solids, a lot more physical mixing and handling up front to try to get it to blend in. It made a decent product in the end, but all that cost didn't make it attractive to continue trying to make compost blends with this as an input. The other factor is these DAF sludge materials are typically also involve a polymer to enhance thickening and the phosphorus recovery, where the digested organics ultrafiltration project is solely mechanical. So some of our end use markets are targeted towards organic agriculture, and use of the chemical polymer would prohibit that from being used. So it limits some of the end market potential. This image is actually centrifuge cake. So there is another device in the state of Vermont on a farm in Sheldon, in Franklin County. And it's been operating on and off over the past several years. And we certainly were informed by it in the sense that they were making this product, but struggled to find a good end use market for it. So we initially thought we were going to have it, but their system never ended up running during our trial stage. So we didn't end up trying it in. I think it could be a successful product. I don't think it has as high of a phosphorus recovery rate, but it does already kind of look like compost or manure solids. So in terms of incorporating it, it could have some good potential. It was just a little dense. So the drying and aeration was a potential benefit of working with this product, and perhaps we will in the future. So how did we do it? This is the prototyping stage, 2019. We set up some small piles within one of the Vermont Natural Ag Products existing barns. The piping came from, we brought in a temporary positive aeration unit that we could enhance with the heat recovered from their existing units. You can see the steam pushing off from the piles. So we had to, these piles were perhaps a little wetter than a typical compost batch by adding the concentrate or other material. And that was the benefit of pushing the heated air through these batches after they reached their targeted time and temperature to be called compost and kill pathogens and weed seeds, but it also dried down the product further so it could be more easily stored, blended, and transported. Just another shot of that. You can see in the background, that's our trailer that had the temporary aeration in it. Again, this is just the screen that we're able to track the process parameters. So the temperature of the vapor, the oxygen levels, the flow rates, and then on the water side, in this case, this is at a high level, but we're getting 156-degree water circulated at 10.5 gallons per minute. And then that goes to a second heat exchanger so that you're able to heat up the ambient air, probably not quite to 156, but to fairly close to that. And that's pretty effective when pushing it through a pile to dry down the moisture level. All right, so on to stage 3. So that's where we are. We did the stage 2 report back in late 2019, and we were very fortunate to get accepted for further funding. The premise of the stage 3 effort was to set up a network of on-farm sites to do a mixture of some of the processes and create some of the blends in further blends that we prototyped in the stage 2. So one of our again, try to collaborate more closely with Digestic Organics. Compost certainly has phosphorus in it, but for us to start moving more meaningful volumes of phosphorus, we needed to collaborate with them to get that concentration. This is a good map that kind of illustrates our focus in northern Vermont. We continue to use a range of sites in different watersheds and counties. Foster Brothers, Vermont Natural Ag Products in Addison County primarily will be a partner later on with distribution. Once we start to create larger volumes and consistent products that can meet the quality demands of their existing line. And then the red star is up in Franklin County, and one of our partners nearby for where we're based, the Magden Brothers dairy. So again, Missisquoi in northern Lake Champlain has some of the highest phosphorus loading rates, so it made a lot of sense for us to focus our early efforts there. Other farms shown here have other needs, either as producers and or end users, or would be good distribution points in addition to using it themselves. So again, we're trying to not only show that this is technically feasible, but more importantly, actually economically viable. So that's really what we're digging into now, and trying this collaborative approach between a network of sites. So as we got into this phase 3 activities, we looked at the different partners who signed on to support the project, and then get into the specifics of where the most viable processing and composting locations on their farms. Again, Tamara Lane Farm, gotten a lot of discussion in the last several days. Smaller farm, so not looking necessarily make our most of our product there, but they could also be incorporate some of the blends into their process and be an end user themselves. Just run through quickly some of the sites details. Each of them have their own unique aspects. The Magden Brothers are a dairy farm based in Fairfield, but they have a second milking facility and dairy in St. Albans. Gives them, they were space limited at their home farm in Fairfield, but also this gave them crop access down near St. Albans Bay that can have different weather conditions. So it was a bit of a hedge in terms of weather being slightly better or worse in the two towns at different years. But ultimately they are interested in the manure separation, both for saving bedding, but this was a new opportunity to diversify their farm revenues and activities and potentially use the heat recovery for composting. So we have a site that we scouted out there, and Jason McCune-Sanders on our team did some mapping and drawings. We also went up to the Schwander family farm. They're closer to the border up in Highgate. They're a little different. They may do some seasonal composting there. They have a bedded pack facility. If people are familiar with that, basically instead of a slurried manure system exclusively, they have these coverall barns where the sawdust, bedding, hay, and other materials are built up over the course of the winter season. And then they do a big clean out of that pack in typically June or early summer. Some of it's directly applied to their pastures or fields, but a fair amount of it they windrow for application either in the fall or the following spring. So they were interested in a way to more efficiently compost some of that material. And then uniquely, because they are selling grass-fed milk, meaning that their animals are not fed any grain, they can get a little premium from Organic Valley for selling their milk in that form. They are no longer importing all that grain. So with their land base, they actually are in a minority example position where they need phosphorus fertility. So they've started to buy in some organic fertilizer to meet those growing needs. So they were interested to see if the phosphorus concentrate and some of the phosphorus fortified compost could be a fit for them. So see if they both use product that they could make themselves, as well as may acquire some from the other sites. So while we were doing this, other tasks that we had to perform for the stage 3 is some market assessment and business planning. Again, the state wants to make sure that they're making a sound investment, that there's actually a demand out there. Got some great help from Jeff Robertson and other advisors through the Sustainable Jobs Fund and developing some market research and business planning. And we didn't want to just be another compost site and compete with some of the folks we're already working with around the state. So we're not, while we may sell some portions into landscape and home garden markets, our intent is to make composts that are phosphorus fortified and more targeted to these agricultural end uses. So some of that being dairy and the corn or pasture or hay applications, but kind of the growing markets of vegetables, hemp, sunflowers, and other opportunities. So some of those do have a particular phosphorus fertility need while also seeking those soil building benefits of compost. The other task is we had to build equipment to carry this project out. Rather than just selling equipment, as we've done is our primary business model to this point, we'd also be involved with operating these network of on-farm composting and phosphorus processing sites. So Jason and Ellen are working at our shop in Cambridge. We again are mounting this equipment into a 20-foot shipping container that will be deployed at one or more of those farm composting sites. And again, being the title of the presentation, I wanted to make sure I answered the question, why are we using compost heat recovery? I think I've covered it fairly well, but again, we're able to move around to these different sites with this modular equipment. It can doesn't have to be deployed if the circumstances change on any of the individual farms or if it's just a seasonal need. And then we can use that renewable thermal energy for that drying process, again, to incorporate more of that wetter, denser concentrate into these blends and try to make it replicable from if we're able to have an impact beyond these initial sites and make it more statewide. Again, the thermal energy, Jason's working on the plumbing system in the unit for this project. That's how we distribute the water and glycol around the system to whether it's heating buildings on site, or in this case, more so for the product drying. And just to show an example of where this has been deployed elsewhere, actually more at a landscape supply place, but Ellen's shot of Ellen out in Michigan last year. this unit's able to aerate 8 different batches at a time. At that site, they're able to do batches anywhere from 200 to 300 cubic yards each. And then they cycle through those aerated bays every 3 to 4 weeks. So I think they're running something like 30,000 or 34,000 yards a year with this single piece of equipment on the aeration, and it's really sped up their process. It also provides heating to their adjacent shop and the greenhouse in a sales building, and they've just built a greenhouse and are going to be plumbing in that for the heat as well. And just to show what it looks like, at the back of the container, these are where the pipes to the aeration zones come in. Jason is setting it up, and we have a sump at that site to handle any of the condensate from all that hot vapor in the pipes, as well as any leachate from the active bays. Here's a view looking out towards the pad during construction. In this case, the pipes were built into recess channels, so a bucket loader can run clean over it and scrape. We also do, some of you have heard the term pipes on grade, where the pipes are set on top of the working pad, and the equipment just has to straddle it and avoid hitting the pipes. Same view with loaded compost and even a coat of snow. And I'm still amazed, even after years in working in this, that you can have that cold fringe of the pile and it'll hold snow. But in that big core of the pile, it's 150 degrees. The vapor gets pulled through pipes underground up into those pipes into the back of the container. And then we're heating the water and glycol up to that temperature. Back to Vermont, zoom back into here. So this is what we've been working on this spring. So originally we were looking with the Magden Brothers at that McQuam Shore Dairy site in St. Albans, but because they still had some construction and cleanup work to do down there, and one of their farms where they raise heifers and calves in Fairfield conveniently had an old feed bunk, which you can see that big rectangle on the far right-hand side of this picture that was not being used. It even had a leachate capture at the north end of it, which allowed any of the runoff from originally feed storage and now compost that drains directly into the manure lagoon. So we didn't have to spend extra effort setting up a new runoff controls or leachate capture and treatment. So we didn't get started with the full compost aeration heat recovery unit there first because we had to buy some pipe. So we used our temporary setup using that same compost heat wagon or aeration trailer to lay out some piles and get started making some batches this winter. So we'd at least have some product ready for the spring. I said it was kind of like training wheels on a bike, because it was also great for the Magden Brothers to get familiar with, they had done windrow composting in the past, but to get used to building batches that would be good for an aeration system, figuring out straddling the pipes, recipes, and all those other nuances. So here's a picture of one of the batches that we're making. Again, the pipes come out of the unit. We had a single aeration blower inside that was just pushing positive, so no heat recovery at this stage, but we got at least more familiar at this site with aerated process. And as Caitlin mentioned, that COVID delays, typically we'd get a pipe order in 3 or 4 weeks. It was closer to I think 8 or 9 weeks to get the order in. May not have just been COVID. I think some of the pipes were going down to Texas and other places that had that big freeze in the winter, and a lot of things that burst. These are just lovely compost shots for people who care about frost and steam coming off of piles on a cold morning. But point being that we did work out the aeration process to my satisfaction at this site, met all the time and temperatures to be considered compost, aerated system being 131 degrees or greater for 3 days. So we've got composted manure mulch. Again, just a nice sunny day, good farm picture of the setup there at the Bernor farm. So just in the last couple of weeks, cleared off those existing aeration lines. You can see the just being exposed a little bit of the pipe manifold. So working with the operator to be careful breaking down the pile so that we don't destroy or break those pipes on grade. And then because there was a lot of chips in this, it won't be just a manure. And we're not going to screen this batch. It'll be sold as a composted manure mulch. So what's coming? Here's some drawings. This is to be placed in that same bunk. If this overhead view in the top left, kind of a 3D view in this lower right. So the pipes will go into the back of the container. It'll sit in that south end of the feed bunk, and we'll be able to do a series of aerated rows using the available space. Lower left, you can kind of see a profile of the different piles in the hot box unit in the center. And just a shot of the unit at the shop with all those will be all those pipe ports that will get to connect to those pipes on grade. The ports at the top is where the exhaust comes out from the compost piles. We are leaving space in that bunk to put in a wood chip biofilter if we feel it's necessary. Either for odor control or noise or not having a plume of steam suspiciously coming out of the back of our equipment in close view of the road. So this is last Friday. The pipes finally came. So they come from a company out of, I believe their manufacturing plant is in Kentucky or West Virginia. So these arrived, and these are some of the long perforated pipes that'll go under the piles. And these are some of the prefabricated sections with the solid sections of pipe that'll connect in to the back of the hot box. We will also do some fusion welding, which is basically a heat process to physically weld together those sections of pipe so that they're a little more durable. We also do use some Fernco couplings to connect some of the other joints. So the last couple slides before I finish the presentation and we get into Q&A are circle back to the ultrafiltration. So again, our expertise is mostly around the composting side, but we're also, in order to really make impact with this project, we need to have that phosphorus concentrate in order to move more of the phosphorus out of the manure, get it out of those areas that have too much, and get it to the places that still need it in a form that people are interested to use. So this is a drawing of Green Dream Farm up in Franklin, kind of near Lake Champlain, Chris and Annie Wagner's farm. So they've been doing some composting for years, but they agreed to host the Digest Organics Ultrafiltration unit. So they've got their dairy barn, they've got an existing screw press separator. The manure will go down to the ultrafiltration unit. Some of it, the permeate, will go to a manure lagoon, and then these tanks in the lower left are where the concentrate will be accumulated. We'll periodically either during the growing season coordinate transportation to field applications, some field trials, whether that's for forages, hemp, sunflowers, or other things, but we'll also be transporting some of it to the Bernor farm and making those phosphorus fortified blends. One of several reasons we were happy to work with Chris and Annie at their farm is they already had a screw press separator in place, and they also already had three-phase power, which the ultrafiltration unit required, and not all farms have. And again, this is the first step. The liquids after the screw press or primary separation go into the ultrafilter, and that device is far more effective if you're not clogging it up with the coarse fiber. And here is the trailer in fabrication out in Michigan. They hope to get it to Franklin, in Franklin County, town of Franklin, later this month. Hopefully we'll stay on that schedule, and we'll be able to get more of their concentrate used in this year's growing season. and start making some for our compost batches. Summarize the next steps. We're going to do some yield trials. One of the great things is some of the yield trials are going to be right with the farms that are also the processing sites. So Magden, Schwanier's, Tamara Lane Farm have all agreed, as well as some other locations, to be trial sites so that we can both evaluate the yield results from using these different products as well as the cost associated with it. We'll do some initial sales to kind of get on the radar of people that this is a new composting site, and we'll have some products for sale this year, but increasingly in years to come. Try to develop some additional product lines that match the customer needs. Further develop more sites, hopefully multiple sites with the Magnens, and some of those sites that we have planned, get them into actual implementation. And then kind of circle back on that business planning, and are we pricing this to match the cost of production, and are we really targeting these products to the right markets? And then for documenting and measuring the impact of this project, we've got to do a lot of tracking. We've got a new member of our team, Jay Grannon. He's going to be helping with us to do some of this effort, tracking all the inbound and outbound flows. We've got a lot of different feedstocks, so it requires a lot of sampling, a lot of spreadsheets, and ultimately it's got to be tied into the nutrient management plans on these farms. So even if you think you're doing the right thing, you've got to track the numbers and prove it, so people will know that this was a good investment from the state and everyone's time. So wrap up with that. Here's again one of the collaborators, other members of the Vermont Phosphorus Innovation Challenge teams, Digested Organics. So there's their contact information. And here's us, our team, Agrilab Technologies, and one of our pieces of equipment on a sunny fall day. So I will wrap up there.
Great. Thank you so much, Brian. This is super interesting to look at and to hear more of the details about your projects. We did have some questions come in, as well as some other resources shared, but I'll just start with one of the questions that Carrie just posted. What was Vermont's investment in this project over the 3 years?
For our company specifically, we got $50,000 in the stage 2 to do the prototyping. So that again was 2018 and 19 to do kind of to set up the equipment down at the Fosters and some other field trials. And then the next round, stage 3, we've got $330,000. So it's a 5-year agreement, and it's those different categories. We had to do additional market research. We have to do a lot of site improvements and cost sharing on the 5 different farm sites. And then we had to build the equipment with some cost share and produce a certain number of yards of material through the system over the 5-year period. So we're obligated to meet a number of targets in a 5-year period.
Great, thank you. Carrie, feel free to unmute if you have any follow-up or.
Hi, Carrie.
No other, actually, great presentation, Brian. Going to get you down to Austin, doing a shorter version of this for the national group. So yeah, just thanks for that information. It was really, and it was a great summary, because towards the end I was like, what's the connection between the heat recovery and the phosphorus? And I was almost missing that. So it was really good to bring that back together at the end. So thanks.
Great.
Yeah, happy to have this much time to talk about it. Pretty rare to have this much time in a conference or a presentation to go into this level of detail.
Actually, unless there's other questions. So I'm now living in Troy. I'm not far from Vermont, and wondering kind of how do I introduce this into New York? You know, I bought compost from a dairy farm just down the road here. He's making compost. Has separated solids, but then he's composting composting those dairy solids and fertigating with the the liquid. Certainly, New York's also in phosphorus surplus situation. So I'll have someone, or if anyone else on the call, if someone wanted to like take this concept and promote it locally, how would we do that?
Long answer probably, but the short answer is there's every farm has its own kind of nutrient dynamics. So some of that's based on their historical land use, some of it's based on their stocking rates of their animals, some of it's based on their soil types and their proximity to the watershed. So you could run through a profile of kind of all those things and try to see where the best fit was in terms of, does this make sense? Is there other farms they can collaborate with? And are there opportunities to distribute the material to an end market that's interested? New York's got the nice advantage of a much bigger population. So on some levels, New York is a better place for compost sales because of the population base. And it probably has more diversified agriculture than Vermont. Vermont's still dairy dependent in terms of its gross agricultural receipts. So yeah, you'd have to spend some time up front to think through where the investments are warranted and which pieces, since we have the benefit of working with a lot of other partners, there may be other equipment or other custom service operators or other folks that would be the right partners to bring in, depending on the spot. So very, very qualified answer, but that hopefully that's a start, and happy to follow up after this to connect directly.
Great, thank you. John Culpepper had shared some information about phosphorus work that he's doing, and I wonder, John, if you might just unmute yourself and talk a little bit about what you had posted in chat.
Hi, Natasha. Thank you. Yes, in upstate New York, we're experimenting with a process by which we take human urine and compost it through a high temperature composting regimen. And we have had amazing results getting high quality compost using nothing more than dry sawdust, human urine, and water. And so this is a very, very non-technological approach to extracting phosphorus and other nutrients from human urine, which is where most of the plant foods that we excrete come from or are in. So for anyone who is interested, I've got a little blog article in the chat, I think, and on our website, Compost for Good, more information on that. But thank you, Natasha.
Sure. Thanks, John. Let's see. Any other? I'm just excited, Brian, to see the trials, like the application of it as you are able to move forward and see. We're going to have you back next year to give us an update on this project, I think.
Caitlin, I didn't describe the sum total, but I believe between the 5 teams, it's like $1 million or something that the state put in for the different projects folks were working on.
Yeah, so the total investment was over $1 million for stage 3. That didn't include the initial amount that was awarded for stage 2. However, I do think it will probably end up being just around $1 million for the whole VPIC project, as there was some funding that was initially awarded to several projects that are not getting funded in full just because of different steps that needed to be completed and that weren't. So yeah, the state will probably end up being right around $1 million invested in these different kinds of technologies. And it will be really interesting once we have more data on your project and DVO and the Village of Essex Junction to see what the savings are for the state in the long term when you think about infrastructure costs that are saved and the water quality benefits. on a higher level. So it'll be something that we'll definitely put together and share widely with folks once we've been able to calculate those numbers.
Great. And I'm happy through CAV's network to share some of those reports once they're available. I can send it out to the group as well.
Thank you.
Your
Great.
chicks again.
Yes.
Yeah.
I love it. Any closing remarks, Brian, or?
We certainly hope, as the state and society in general opens back up over the next several months, that we'll be able to offer tours and things of that. So maybe July, and we'll keep in touch. I know Compost Association historically has tried to do 1 or 2 in-person tours a year in conjunction with our periodic board meetings. So certainly 1 or more of these locations would be welcome to take folks through. I'm just grateful to get a chance to work on not only with the farmers, but I've also been outside of composting, been involved in watershed projects in the Missisquoi River Basin and Friends of Northern Lake Champlain. So yeah, definitely also personally impacted by having taken our daughters to the lake and seeing algae blooms and stuff like that. So having the opportunity to mesh these different aspects of professional work on something local is definitely meaningful.
Great. Thank you so much. And for those who are local to us, the CAV meetings, whenever we're able to meet again in person, we usually meet 3 times or so a year, and members are always invited to join in those meetings with the board as well. So just a little plug for joining the Composting Association of Vermont as a member. We're open to organizations, municipalities, composters, haulers, concerned citizens, and anyone else who shares our vision and mission. So yeah, we're getting a lot of thank yous in the chat, Brian and Caitlin. So thanks so much for sharing the project. And I'm really glad that we were able to do a deeper dive on it, Brian. It's been a lot of fun. Thank you to all the participants for taking another little bit of your day out to spend with us at the Vermont Organics Recycling Summit. Just a reminder that we do have 2 sessions left, both at 3 p.m. today, concurrent sessions: improved compost fertility characteristics, thermophilic and vermicompost blends, and then a virtual tour of the Chittenden Solid Waste District's organic diversion facility. And then the program continues throughout the week. And I just because John Culpepper had mentioned his work with human urine, tomorrow's virtual tour is actually with Rich Earth Institute down in Brattleboro, and that's their focus area as well. So for anyone who might be interested to learn a little bit more about that, please feel free to join in that virtual tour as well. And I hope to see some of you soon. And last plug, at the end of the week, you will all be getting an email with a link to an online evaluation. So please take just a minute or 2 to fill that out for us. We really appreciate your feedback. And with that, thanks so much, everybody. And I'll see you in about 45 minutes for those of you who can join us for the next session.
Thank you.
Take care.
Take care.